Pankhurst's algorithm is used for deadlock avoidance. So this is the safety algorithm. So here we use the four variables. The first one is available. The available gives that the number of available resources, and the next one is need. So the need gives that the remaining need of resources, and the next one is max. That maximum gives that the maximum demand of each process, and available. So available, it gives the number of available resources. So how many variables? The four variables we are using. So those variables are, the first one is the number of available resources, and the number of allocated resources, and the maximum demand of each process, and the need of each process to finish the execution. So here in this safety algorithm, the first initialize the work is equals to available, and this finish of I. So here I represents that number of processes. This finish of I is equals to false. So where I is equals to the 1 to n minus 1, the set of processes. So here the first we have to initialize that the finish of I is equals to false. After that we need to check that the need of the resources or less than or is equals to that work. That means if the need of the process is less than or is equals to the number of available resources. If that condition is true, then we can add that this available resources to that already allocated resources. So that means it will increase the now available resources. Then change that finish of I is equals to true. Okay. So then again we go to the next, check that condition. Again the maximum need of resources or less than or is equals to that now available resources. Like that we have to check that condition. Finally we will move to that when this finish of I is equals to true for all processes, then the system is in safe state. Okay. This is the algorithm of the safety algorithm. This is safety algorithm used for deadlock avoidance. So here by using this safety algorithm, we can say that these processes are in safe state, these processes are in safe sequence or not. Now let us consider this is one example. In this example, you consider that the P1 through P4 are the processes, and the three types of resources A, B, C are the three resources, and each resource having the 10 instances of resource A, 5 instances of resource B, 7 instances of resource C. Now from this 10, 5, 7, for each process the operating system allocated this number of resources, and but to finish the execution of the process P0 to P4, the maximum demand of the each process to finish the execution. Here that means for the process P0, it holds that 0 resources, but to finish the execution of the process P0, it requires that 7 resources to finish the execution. Okay. So now like that, from this 10 instances from the resource type A, already these 7 resources are allocated. So that means now what are the available resources of the 7 resources are allotted to the process P1, P2, P3. Now that from resource type A, the 3 instances are now available resources. From the resource type B, okay, the total 5 instances. Among these 5 instances, so here the 2 instances are allotted to the process P0 and process P3, and the remaining resources are the available resources 3. Now coming to this C7, C. The resource type C having that 7 instances. In this 7 instances, how many instances are allotted? The 5 instances are allotted. The remaining available resources are 2. Now we need to know the maximum need of each process to finish the execution. How we will get that need of the each process? So we will get this need of the each process by the maximum demand of the each process minus allocation. Okay, the max minus allocation, this maximum demand of the each process minus allocation will give that the need of the each process. So now for the process P0, for these three types of resources A, B, C, these are the need of the process to finish the execution. Now we will see that if all these processes are in that same sequence or not. Now first see that the first available resources are 3, 3, 2 are the available resources. The first check that condition, the first initialize the finish of I is equals to false. That means now we are starting with that process P0. That means finish of 0 is equals to false. Finish of 0 is equals to false. Now what we have to do? We have to check with that the maximum need of the each process is less than or is equals to the number of available resources. So now if you consider that first process P0, the first check that condition, the available resources are 3, 3, 2. We have to check this condition for 3 resource types. Is this true? The 7 instances, here the 7 is greater than 3, 4 is greater than 3 and 3 is greater than 2. Right? Now this condition is false. Now we have to check with that next process. Now check with that process P1. For this process P1, so the need is 1, 2, 2 and the work is equals to 3, 3, 2. So it satisfies the condition. Now when it satisfies this condition, need less than or is equals to work, we'll move into that next step. The available is equals to available plus allocation. Now what are the available resources? 3, 3, 2 are the available resources. Now process P1 use these available resources. After that we have to add these resources to available resources. Now we have to add that for the process P1 to 0, 0. Now how many available resources are there? 5, 3, 2 are the available resources. Now we'll move into the next process P2. Okay, if that we have to check like 6, 0, 0 is less than or is equals to that 5, 3, 2. No, this is not satisfied. So then we'll move into the next process. So here now the available resources are 5, 3, 2. Now here the need of this process P3 is 0, 1, 1 only. Now the process P3 can use that available resources. Now this condition is true. Now that finish of 1, 2, 3, 4. So these are all resources or first processes or initialized with that false. Okay. So when it finish that one, it will change to true. For the first process P0 is not satisfied. Sorry. The process P1 satisfies the condition. So it will change to true. Again we check with that process P2. Then this is also not satisfied. Now we move into the process P3. In the process P3 it satisfies that condition. Now add this process P3 allocated resources to available resources. Now how many available resources are there? 7, 3, 2. Now we will move into that process P4. Okay, 7, 3, 2. Okay, so here the required processes are 4, 3, 1. Okay, so here this is less than or is equals to 7, this is less than or is equals to 3 and this is 2. Now we will move into that process P4. So it checks that it satisfies the condition. Now we will add this P4 values.